Today, there are many challenges facing humanity, whereby a series of issues that are reaching a tipping point are inextricably linked and together compounding to create a much more riskier future for our global systems. The challenges of this polycrisis create a complexity never seen before in society. Now, what if there was a publicly accessible way to face this complexity, to unlock the human ingenuity that exists at all four corners of our planet?
Imagine being able to replicate the symbiotic harmony of a rainforest ecosystem, to harness the organizational brilliance of a mycelium network, or to know the ancient secrets of trees. Neuromorphic quantum computing is the next quantum leap that redefines intelligence and consciousness in the digital age, driving breakthrough solutions across nature, society, health, and space.
My name is Louis Levent Özcan. I'm a British-Turkish documentary filmmaker specializing in telling stories of systems change. Along my journey of looking for systems change that could address this complexity, I came across a company called Dynex. Dynex is innovating at the intersection of quantum physics and neuroscience to develop an unprecedented solution for this great complexity and these great times. But where does the computational epoch begin?
My name is Caitlin Nykum, and I serve as the investment analyst and communications leader at Dynex Moonshots. The emergence of computers reflects humanity's profound drive to unravel and master the intricate tapestry of our existence. At its core, this pursuit embodies our insatiable curiosity and relentless quest for understanding.
Problem solving is as old as humanity itself. It is a process and a cognitive function that has allowed us to face the challenges throughout history.
My name's Clifford Mapp. I'm the Global Head of Ecosystem and Information Security at Dynex. I mean, we can go back to something like the Antikythera mechanism, considered the very first computer that was built in Greek times, which was tracking solar, the very first example of computation, right? Working out where the stars were. Analog PCs were built with bulbs, wires, pretty much anything that they could send us signals through at the beginning, right? They were the size of large rooms, if not small buildings. A lot of computers back then would have been very niche. So you'd have a tide predicting machine or you'd have a weather predicting machine. They wouldn't all be just considered one machine that could be general purpose.
Is its new differential analyzer. This amazing mechanical brain quickly solves mathematical problems that would require months by ordinary computing methods.
The transition between analog and digital, it truly was the invention of CPU, RAM, and actual general purpose hardware that truly made that leap forward.
In the latter part of the 20th century, the quest for understanding and mastery of the world took a revolutionary turn with the advent of personal computing. Visionaries like Apple's Steve Jobs championed the idea of placing a Macintosh in every household, democratizing access to computational power, and making technology an integral part of everyday life.
But today, for the first time ever, I'd like to let Macintosh speak for itself.
Hello, I am Macintosh. It sure is great to get out of that bag.
And this movement was not merely about distributing machines. It was about empowering individuals, fostering creativity, and connecting humanity in unprecedented ways. In this relentless march toward knowledge and accessibility, personal computers also stand as a testament to bring the power of understanding into the hands of the many rather than the few.
So of course, we're at that stage where we were at just before we transitioned from analog to digital. We're now at that stage again between digital and quantum. There's an actual scale actually predicts the crossover point, shall we call it. It's called the von Neumann scale. That forecasts where the processing capability of an ordinary CPU, where it will plateau. Because if you can't go smaller and you can't push more energy into it, you're either redesigning what a CPU is, or you have to take that next leap into quantum. And that's where we're almost at that tipping point right now. What we have today is going to be eclipsed tomorrow. Quantum is a very large subject, niches within niches, effectively. And neuromorphic quantum is one of those niches.
So first of all, quantum is just something that has always been there. It's just that we had to invent ways to look at matter that was small enough. But all the matter of the universe has always been working that way. And it's really hard for us to conceptualize because our brain is made to understand what we can see at our scale. Perhaps we look at the objects around us, how they move and everything, but no one has observed with only their eyes the properties of quantum. That's why it's so hard to conceptualize. With all the experiments that we've done in the last 50 years, we've spotted that when you take matter that is small enough, it has some precise way of behaving that is very different. If two photons are created in the way that they are entangled, so if you modify the orientation of one, it will modify the orientation of the second one, no matter how far apart they are. For a classical computer, you need to have 5 little objects that are either in 0 or 1. You can only choose one of those. And for quantum computers, you can have both 0 and 1 at the same time. So we call that superposition. So that's why it has a possibility to be really fast. How did we go into neuromorphic? Nowadays, the goal of computation is to compute real-life problems. And we know so much about how the brain works now, and it's actually organized with a lot of parallelism. Many different paths working at the same time to gather information. We took the basic components of classical computers physically in a way that looks like the brain, so more parallel, and it becomes better at spotting patterns and apply it to components with quantum properties.
The mission started logically with thought process always over many years, right? But we really put our sleeves up in 2020. We had several reflections. You can call it utopic thinking of trying to solve the problem also of Moore's law ending. If Moore's law is ending, computation will not be available for everyone anymore. And we explored these research papers, this tremendous work that has been done, for which we are enormously thankful. We came to the conclusion, because of the performance figures available on neuromorphic supercomputing at that time, that we would like to explore how we can build a so-called digital twin of what could have been, if you would have strictly followed the research papers, a physical, neuromorphic quantum computer, if you want. We started aggregating a tremendous team together, which you will see during this film sequence. And this team grew. This is today a leadership team of amazing 12 people, truly having started in the garages. Actually, the first calculations we did with the algorithms, etc., were in a garage. And now we do have a neuromorphic quantum computing cloud available to everyone, and it's the world's first.
On the graphics cards that we have on our network, when you connect to our network to provide us computation, we create an artificial quantum environment on your graphics card that allows us to then run quantum simulations and algorithms. Decentralization for what we're doing is practically unheard of on the scale that we're producing it. Obviously, there's been plenty of neuromorphic networks set up, there's been plenty of quantum networks set up, but none have ever tried to run it over a decentralized platform where this allows us to spread over multiple locations, multiple devices. Not only is it no longer a single point of failure, but also it's infinitely scalable.
Hi, I'm Ivan, the Global Head of Platform Development at Dynex. We strongly believe that the future lies in distributed computing, where everyone can participate or use it, which ideally fits in blockchain concept. We chose to build our own blockchain because it ensures transparency and security in data handling, which is crucial for our distributed computing model. Imagine, right now Dynex is a huge computational blockchain with over 100,000 GPUs distributed worldwide. GPU providers receive benefits in the form of Dynex tokens emitted by blockchain, which also helps us to build a healthy digital economy. The power of 100,000 GPUs inside your laptop is available from anywhere in the world to compute our future.
We have an entangled network, so we run a proof of work consensus mechanism to secure our network. And then we've got what we dubbed proof of useful work, which is our quantum environment, because it's doing more than just normal cryptocurrency or block hash verification. It's doing something in the real world that actually has a use case. It's biology inspired.
As we developed the neuromorphic quantum computing cloud solution, we saw many advantages it brings and carved out the 5 most important advantages in the 5-point advantage model to make it easy to understand for everyone.
The cost to efficiency ratio is ridiculously through the roof, right? Because suddenly, instead of you paying $2,000 an hour, you're paying $99 for an entire month. The more you supply it with data, the more infinitely efficient it becomes.
From an energy perspective, this is far more energy efficient than any quantum computer.
All jobs are effectively encrypted both in and out of our solution. Everything that is run on our system leaves a digital fingerprint.
With integration through the SDK library and subscription available through your browser. All of these advantages support the entire ecosystem to engage. If you take use cases, for example, let's take healthcare, protein folding, RNA folding. If you take multimolecular analytics, you have it also for large language models in AI, or in the pharma sector, where you can suddenly model the multi-use of medicine. All of this is now possible at absolute speed.
Hey guys, this is Sal Rahmeh. I'm the head of quantum solution architecture at Dynex.
And today we've got a few different demonstrations for you. Hitting the realm of science fiction is Alcubierre's warp drive. What is a warp drive? A warp drive is a theoretical construct for a faster than the speed of light style of propulsion. At the moment, obviously it's all theoretical because we can't quite generate that kind of energy, but we are able to simulate the warp drive and the warp scale.
When we talk about the warp scale and what does it entail, we're talking about when we start the first step and end with the last step. So the quantum annealing here calculates each step individually.
And this is just a really good example of really out-the-box thinking.
Democratizing technology gives the people the right to innovate, to create micro, small, mid-cap businesses, alleviates the macro surrounding of an economy, alleviates the status of a civil society, and logically gives also the people the right to influence and contribute to their own prosperity.
I'm Bebop Gresta, the co-founder of Hyperloop GT and founder of Hyperloop Italia. In the last 10 years, we've been developing the Hyperloop technology. Imagine to have a capsule of 28 people. You put this capsule inside the tube, so you have no resistance. And now, because there's no resistance, you can levitate and move the capsule at almost the speed of sound. Imagine what we can do if we can tap at an unlimited amount of computing power, like a neuromorphic quantum computing of Dynex. This would be revolutionary. We could create a digital twins of the Hyperloop and simulate all the components of the Hyperloop even before we built it.
Hi, here's Felipe Spielman from Bluebell Index, a company that values, certifies, and monetizes environmental assets. We certify not only carbon, but carbon, water, soil, and biodiversity. And all data that we certify, we use Dynex computers as an index.
Hi, my name is Stan Chen, and I am the CEO of RecycleGo, an AI and Web3 driven platform that provides unparalleled visibility into supply chains. I am looking forward to working with Dynex and its quantum computing technology in order to build and validate our models around how climate change is disrupting the world's supply chains. We need to deploy all of humanity's resources at this point in order to build a more sustainable future, and I believe Dynex provides us the tools to do just that.
Hi, I'm Nicholas Riancho, the project lead and liaison for Resilienture. Resilienture, or Resi for short, is a new mission-driven business focusing on building resilience for coastal ecosystems and communities. Resi is excited to be partnering with Dynex Moonshots to leverage the power of quantum computing to model and predict climate change effects. By using Dynex's awesome quantum computing abilities, the deployment of comprehensive plans to protect coastlines, conserve natural environments, and encourage biodiversity can be sped up.
We stand on the brink of unprecedented climate challenges, and I believe that Dynex technology has the potential to impact lives and drive significant change. Democratizing access to neuromorphic quantum computing is the first step toward a future where humanity can truly move forward together.
So it sounds a bit futuristic, and then you let it settle, and then suddenly any bridge you see, it really makes us overcome a certain complexity that we were not able to overcome as easy as it's now.
Routing hyperscale algorithmic problems to the decentralized Dynex platform's non-physical mirror of quantum compute time begets questions at the edge of technology, philosophy, and society. I regard Dynex Moonshots key to safer answers.
At Dynex Moonshots, an initiative within the Dynex ecosystem, we serve as the investment, strategic, and ethical steward of the ecosystem, providing access to this groundbreaking technology.
In Dynex Moonshots, I leverage my experience in the field of financing innovation, computing architecture, and sciences to foster the most innovative, world-class endeavors.
Our mission at Dynex Moonshots is to propel ambitious endeavors, we call them moonshots, by granting access to Dynex's neuromorphic quantum computing cloud, enabling rapid advancements in academia, research, and industry, while also offering investment to visionary companies and institutions that are pioneering solutions. As with every great technological leap, technology intended for good purposes has also been leveraged for nefarious purposes, and quantum is no different.
To
purpose of the ethical committee is quite simply to ensure that this tool, this new, extremely powerful method, is only used for what we would consider to be positive and ethical projects.
Together with my distinguished colleagues from across the globe, we will assess critical projects to ensure that human progress is achieved in a holistic way, benefiting all.
Myself and my colleagues, we're responsible for making sure that every application of Dynex's incredible technology is applied in accordance with international best practices and the highest standards that are available.
From a regular meeting cadence to a routine review process of jobs proposed to be run on the network.
And right now, our world, our society needs more peace and harmony.
In times of unprecedented opportunity and threat, the Dynex Ethical Committee aims to ensure that the quantum computing capacity is deployed in support of the most impactful, sustainable, and inclusive developments.
Which is why Dynex, through Dynex Moonshots, has established a world-renowned ethical committee consisting of global leaders to evaluate select Dynex inquiries to safeguard the integrity of the Dynex ecosystem and the use of its technology.